is I have this function set up, and that function is the basic component to any exponential graph. So you'll want to take that down, and you'll also want to get out either Desmos or a graphing calculator and follow along the different graphs that we plot. So pause the video as much as you need to in order to do that. Great. So the first thing we're going to look at is this B component. This B component is if I were to say something like just any little thing. So in other words, B is like saying I have something like 3 to the x, or like something 4 to the x, or like something even totally different, like 1/2 to the x power. So those are the kinds of things we're looking at right now. It's just b to the x. So what I'm going to do is play this, and this is for b, as you can notice, between 1 and 10. So this is the actual exponent, not e, but numbers like 1.01 to 2 to 3 to 4. And just notice and watch what's happening with this graph as we go between 1 and 10. So positive numbers greater than 1. So you can see now it's playing, b is decreasing, and notice it's getting a little wider, and then of course it gets very wide. Now as b increases, it gets very steep. Very, very steep. And then it'll start getting wider again as the b decreases down to almost 1. So I'm going to pause that and leave b alone for now. Go ahead and write some generalizations down. Anything you can think of for an exponent between 1 and any positive number, so greater than 1. Great. Now that you have that generalization down, let's look what happens with this a. This a is like saying that I had, again, something, let's pretend it's 2 to the, well, it would be like 3x, or 2 to the 0.5x, or even 2 to the negative x. We won't look at that quite yet. So I'm changing the number in front of this x. That's what this a means. So we're going to look at this function again, and we're pretending like this b is 2, and we're going to see what happens with this a now. So just what we expected, when the a is bigger in this equation, when it's greater than 1, it gets very, very, very narrow. Very, very narrow. And then something peculiar happens when we get to negative numbers. So notice negative, negative, now positive again. Positive gets steeper, gets wider, gets wider, gets wider. And then when is this graph going to flip? Can you tell when this graph is going to flip across the y-axis? Notice right now it looks like this. And just there it flipped. So what happened was the a is negative now, and a negative exponent makes that graph flip. So a negative exponent makes that graph flip. So let's pretend we're looking at this g of x function now, this one right here. If I'm talking about a negative exponent, that would be like saying, well, a negative x, so 2 to the negative x. And what is that function going to do? Well, we have an exponent rule to describe this. We have a rule that says h of x, so I'm just rewriting this g of x stuff. This equals something particular. Do you remember what 2 to the negative x is? Any thoughts? It turns out it's exactly the same thing as saying 1 over 2 to the x. And if that's correct, then this g of x will match that graph. So let's see. Yep. Notice how the purple becomes orange, because those are exactly the same graph. And I'll just unhighlight that one so you can see. These are exactly the same thing. So when this A stuff gets negative, then this graph is like saying 1 over 2 to the A power. And do you remember what you wrote down for what happens when this gets negative? Or notice when it's a fraction? Let's look again. What happens with this A? So it's positive, positive, positive. It looks just like this. It's getting steeper and steeper. Now it's going to get wider and wider and wider and wider. And and then it flipped. And notice that it flips when this A number, when this power is negative. When this power is negative. And the connection that I want you to make, that having a negative A is like having a fraction here. A negative A here, so let's move that over, now it's negative. It's like having a fraction here. That's a connection that you've got to make. It's very important. Great, so now I'm going to make this A positive again, just so we can see what happens with this K. Now, you might know exactly what's going to happen with this K here. I'm adding something to the entire function. So most likely, it's going to do just what we would expect it to do. I wonder if you can think of what that is. Do you have an idea in mind? Well, let's see. So this K is increasing, and notice that as it increases, it just moves the entire function up, and then the entire function down, depending on whether K is positive or negative. So just like the way an intercept works is exactly the same thing. This is just like our K in the unit 2 transformations. It's moving the entire function up when it's positive, and it's shifting the entire function down when it's negative. Something else to note is usually when we're talking about an exponential, we have something called that very, very peculiar word. So we're going to look at this one again, 2 to the x. We have a line right here. Do you remember what that line is called? It's imaginary, but it's also kind of there. That's right, it's an asymptote. It's a horizontal asymptote because it's going from left to right. And this line right here is called y equals 0. So it's a horizontal asymptote at y equal to 0. That's because here there's no k, it's plus 0. So notice that when we change k, like what's happening here, and we're looking at this function again, when we change k, we're also changing the asymptote. Notice that that line is changing, the flat line. So here, the asymptote is at 3.8. If I press play again, now the asymptote is at 7.8. And so on and so forth. I want to make sure that this is really clear. So I'm going to pause that. I paused it at a negative 6.1. And so I'm just going to graph that line right there, a negative 6.1. That's where I'm getting it from, this number that keeps changing. And just what I promised, this line matches. In fact, if I zoom in a little bit, you can see that the asymptote is indeed correct because the line looks like it's touching it, and I know it really does look like it's touching it, but it never does. It's just getting really close, infinitely close. So at this point, what you can do now is talk about this general function, b to the ax plus k. You'll know what happens when b is greater than 1. You know what happens when a is positive or negative. And you know what happens when k moves between positive and negative numbers. It shifts the function up and down. There's one last case that I want to look at. And so let's just change this k back to plain old 0. Let's make the a something plain like 1. And I'm going to change this b to 0 to between 0 and 1. So now I've made the b. And before, remember, we were making it greater than 1. Now it's between 0 and 1. Now it's between 0 and 1. So at 1, yes, it's just a line. Forget 1. Let's look at what happens, though, as it gets closer to 0 and then back up. So notice that it's on the other side of the y-axis. And it's getting wider and wider and wider. So as b gets closer to 1, it gets very wide. As b gets closer to 0, it gets very tall. Now why is that? We kind of talked about it already, actually. We talked about this function here, this h of x thing. Notice that this h of x is also flipped. It's opening toward this left side. And so this is what happens when you have this b. This b right here is, of course, representing a decimal, which we could also call a fraction. That would be the same kind of idea. So in other words, a fraction or a decimal between 0 and 1 will always make this thing flipped this way. So anytime you see any type of function that's a fraction to the x power or a decimal, so in other words, something like this, and I'm going to raise it to the x power. It's going to do just what you think it's going to do. It's going to be flipped on this side. And remember, what do I mean by flipped? Well, I mean that usually when we have like 3 to the x, it goes, it's flat on the left side and then goes up on the right side. These flipped ones I'm talking about are reflected across the y-axis and they're flat on the right side, and then they start to go up on the left side. You should also note that all of these points, when the k is 0, are always going to hit the graph at 0, 1. Always. As long as the k is 0, and as long as there's not a number in front of the b. So we'll get to that tomorrow. For now, know that you have a quiz, and that you should be able to make some basic generalizations. And so let me type up some of these generalizations now, and we'll see how you can do. So here's the first one. And what you're doing is imagining what this graph is going to look like. I'm going to reveal all of them to you. You can also graph them on your own. I'm not quite done with this one. So I'm just adding one more graph. And these two should be very clear. These might be a little trickier. This is our most basic form of the exponential. Once you think you have an idea and you've sketched it out, go ahead and press play again. That's what 4 to the x looks like. Now press pause and do this one. Great, let's see what this one looks like. Okay, it's reflected across the y-axis because it's a fraction. Press pause again and sketch this one out. Great, so this one is steeper because of that 2, it's the purple one, and it's reflected across the y because of this negative. And now, let's look at this one. Have you got it sketched? If not, pause it and sketch it. Alright, there it is. So it's got a vertical asymptote at this number. Remember, it's y equal to k, so y equals to 4 is the new asymptote. Horizontal asymptote, I'm sorry. And it's getting steeper because of that 2. There's no negative and no fraction, so it's opening just like always. It's flat on the left side and then goes up on the right side. As one last challenge, and if you know this one, then you got it all down. Let's see. Let's see if you can get this one. So there's a lot of things going on in it. We haven't talked about this one specifically because I didn't show you an example like this, but you have all the tools to be able to do it. So press pause, do your best. Alright, let's have the big reveal. Let's see what it looks like. So you might have thought that it was going to open on this right side and then go, or be flat on this right side and then go up on the left side. But it's a fraction and has a negative, so in a way it kind of cancels that whole idea out, and so it just makes it work like normal. And then again over here we see this negative 5, so there's a horizontal asymptote happening at y equal to a negative 5. Great, see you guys in class.